Now that we've finished the work with our trig functions of acute angles with our basic definition of the trig function of an acute angle being the ratio of the specific sides of a right triangle, and then we looked at trig functions of special angles both in degrees and in radians, we're ready to move on to the trig functions of any angle. Now, when we're working with the trig functions of any angle, there's several different types of thought process that we'll go through, and I'll try to make sure that I give you some kind of hints and tricks and tips to be able to figure out what it is that the question is asking you to do, and then how you need to leave your answer at the end to answer the question appropriately. So here we have the definition of trigonometric functions of any angle. So this says if the point P with coordinates x comma y is any point on the terminal side except for 0, 0. So we're not talking about it being something where you're not off the origin. It has to be a point along the terminal side that's not right at the origin. So then of an angle theta in standard position, so remember an angle theta is in standard position if its vertex is at the origin, its initial side is along the positive x-axis, and if you go up and around for that angle theta, it has a positive measurement, and if you go down and around for that angle theta, it has a negative measurement. So we have that in standard position. And r is the distance from the origin to the point. So you might have that terminal side of the angle going like further along, but they give you an ordered pair of point on the terminal side. R is the distance from the origin to that point on that terminal side. Then the 6 trigonometric functions of your angle in standard position, so they just named it theta here to have a naming reference in the definition, are the sine of theta is equal to the y coordinate of your ordered pair point divided by r, that distance from the origin to the point on the terminal side. The cosine of that angle is equal to the x coordinate of your ordered pair divided by r. The tangent of theta is equal to y coordinate divided by the x coordinate. And then the cosecant of that angle theta is equal to r over y. And remember, also we noticed in a previous video that your cosecant of your angle has the reciprocal ratio than the sine of that angle has. The secant of theta is r over x. The secant of your angle's ratio is the reciprocal of the ratio of the cosine of the angle. And the cotangent of the angle is x over y. So the cotangent of the angle has the reciprocal ratio than the tangent of the angle has. So that's our definition that allows us to then expand from not being stuck just in right triangles, but to be able to go throughout an entire gamut of different angles that might be given to us. And it's also true that r, this r that they're talking about, is the square root of x squared plus y squared. And this is just from the Pythagorean Theorem. And in fact, each of these, if we start by just looking at it in the first quadrant angle, and then we'll make some extension of how we can look at it in the other quadrants, this makes total sense from the definitions that we had before. And so if I ever start to get confused about these, I can go back to the idea that when we have our x-axis and our y-axis, and we're doing a positive angle in standard position just in the first quadrant, and we bring down our vertical line off of where that point xy would be, then just kind of looking at it here, and we'll see the extension into the overall full cycle of things. Well, if that's my theta, then remember to get to a point. I start at the origin and I go horizontally along for the x-coordinate and vertically for the y-coordinate. So this horizontal run would be the x value of the point. This vertical run would be the y-coordinate of the point. And then when I think about looking at the Pythagorean Theorem, in this right triangle, we have leg squared plus leg squared is the square of the hypotenuse. So my hypotenuse here would be the work with the square root of the leg squared plus leg squared, because if I just did it leg squared plus leg squared, it's the square of the hypotenuse. So the hypotenuse itself would be the square root of x squared plus y squared. But to kind of simplify things, we call that r. Now, if I have this as my angle of focus, remember the side opposite the right angle is the hypotenuse. So r is my hypotenuse. And the side that helps make that angle is the adjacent side. And the side opposite that angle is the opposite side. And I know I have to be talking about this angle theta and not that angle up there, because theta by definition is in standard position. Its vertex has got to be at the origin. Its initial side is the x-axis, positive x-axis, and it's the rotation to get to the terminal side. So it all kind of blends together. It dovetails with what we had before. So now when I think about the definition of the sine of an angle, it's the ratio of the opposite over the hypotenuse. So here it would be y over r. The cosine of this angle is going to be the ratio of the adjacent over the hypotenuse, so x over r. The tangent of the angle is opposite over adjacent, so y over x. And then the cosecant of the angle is the hypotenuse over the opposite, so that would be r over y. The secant of the angle is our hypotenuse over adjacent, so that's r over x. And then the cotangent of the angle is the adjacent over the opposite, so x over y. So these don't give you a different definition than we had before. It starts with that definition, but then says, okay, how are we going to talk about and think about this so we get the right values if we go out of quadrant 1? And then also, what do we do if we're right on an axis instead of being into the quadrants of either 1, 2, 3, or 4? Well, those sorts of questions are answered by our definition of our reference angle. And then after the work with the definition of the reference angle, we're also going to look at what happens if you are specifically on an x-axis or y-axis, etc. So let's next do the reference angle. So for our definition of our reference angle, given an angle theta in standard position, so again, vertex is at the origin, initial side along the positive x-axis, and you do the rotation to the terminal side. If you're going up and around to get to the terminal side, it's a positive angle. If you're going down and around to get to the terminal side, it's a negative angle. Its reference angle, theta with a prime on it. So whatever the name of the angle is in the problem that you're working, you're going to do that angle with a prime on it for the reference angle, is the acute angle formed by the terminal side of theta and the nearest x-axis. So the nearest x-axis. Whenever I'm doing these reference angles, I need to go to the nearest x-axis. So for this first part of our example section of the video, we're going to find the exact value of each of the 6 trigonometric functions of alpha, an angle in standard position, whose terminal side contains, the first point is the point -5, 12. So when I think about this, I want to draw my xy axis. And just like in algebra class, your very first introductory to algebra class, and you're plotting points on an xy plane, our point -5, 12, we're going to go left 5, up 12, and draw our dot. So left 5, up 12, draw our dot, and then our alpha is in standard position, so its vertex is at the origin, its initial side is along the positive x-axis, its terminal side goes through that point, negative 5, 12, and alpha is this angle right there. Okay, so that's the angle we want to find the trig ratios of. And this time, unlike when I know the degree or radian measure of an angle, and I could say like the sine of that specific numerical value for the angle measurement or that specific degree for that angle measurement, here I don't specifically know what the angle is, and it's not asking me to find the angle, it's asking me to find the trig ratios. So I'm just going to use its name in the trig functions acting on it as a reference, looking at using its name in the trig function on the angle instead of having any specific measurement there. Remember, the sine of any angle in standard position where you have a point along the terminal side is the y coordinate over r. Now, we do need to find r for this before we get going on our trig ratios. And remember, r is equal to the square root of x squared plus y squared. So here, r is equal to the square root of negative 5 in parentheses squared plus 12 squared. So that gives me the square root of 25 plus 144. So that's the square root of 169, which gives me 13 for my r. Now, some of these types of values for your leg measurements, the two different leg measurements of your right triangle and your hypotenuse, sometimes when you send it through the Pythagorean Theorem, you have a situation where all of the values are rational numbers. Then I have a Pythagorean triple. Now, sometimes I won't have that, and I'll have a radical that will be within the trig ratios, and I would have to like rationalize the denominator so I don't leave the radical in the denominator. But here I got a rational number for the simplification of it. And another thing I want to bring up, just so we're careful not to do it, remember I have to put the negative sign with the number in the parentheses that's getting squared. And a negative times a negative is a positive. So that's going to be positive 25 plus my 144. Also, I have to add these together before I take the square root. You cannot break the square root up over an addition or a subtraction. You don't get the right answer doing that. So you needed to make sure that you added the 25 plus the 144 to get the 169 and then simplify that radical after you've found the sum. And here we got 13. Your r will always be positive. So it is the distance from the origin to the point, so it's always positive. So now, coming back to our ratios, the sine of alpha is the y coordinate over r, so that's 12 over 13. The cosine of your angle alpha is the x coordinate over r, so that's negative 5 over 13. The tangent of your angle alpha is the y coordinate divided by the x coordinate. So that's 12 divided by negative 5. But usually when we write that simplified, we think, oh, well, a positive divided by a negative is overall negative. So I can write this as a negative 12 fifths or have it with a negative 12 over the 5. But we usually don't leave it in the denominator. Now, our cosecant of alpha, well, cosecant of alpha is r over y. So I have my r13 over my y of 12. My secant of alpha is r over x, so 13 over negative 5. And then our cotangent of alpha is going to give me x over, I'm going to get the ratio by x over y. So -5/12. So just kind of thinking forward with this, eventually we're going to have where they give me one of the trig ratios and they're going to tell me what angle or what quadrant the angle is in. And I have to make sure I realize that when they simplify those ratios, the negative sign might not necessarily be where it's supposed to be when I'm plotting out my points. So I have to go along with the idea of, well, how would I get to that quadrant and which of the coordinates would have to be negative to get there to do those sorts of problems in the future correctly. Okay, so that's our first example. And we wanted the 6 trigonometric functions of alpha, so the 6 trigonometric ratios of alpha. So right here, that is your answer to that part of the question, or to that question. Okay, let's do B. So for B here, I have my point being -2, -3. So when I go through and I again draw this, I'm going to go left 2 and down 3. So left 2, down 3 gives me this point. So my angle alpha for that question is this angle. Okay? And my ordered pair point is -2, -3. Finding r. R is the square root of x coordinate squared plus the y coordinate squared. So I get r is equal to the square root of, well, -2 squared is 4 and -3 squared is 9. So 4 plus 9 gives me a 13 in there. So I have the square root of 13. And that doesn't simplify anymore. There's not even any perfect square factors that I can bring out part of it. So now when we go through and find the sine of alpha for part B here, for this idea, we have sine of the angle is the y coordinate over r. So -3 over the square root of 13. But I need to rationalize that, so I'm going to multiply top and bottom by the square root of 13 to get -3 square root of 13. I'll write it underneath. So the sine of alpha is -3 times the square root of 13 all over 13. The cosine of alpha is going to be x over r. So -2 over the square root of 13, which when I rationalize is -2 times the square root of 13 over 13. The tangent of alpha is equal to y over x. So -3 over -2. But a negative divided by a negative is overall positive. So I'm going to have that the tangent of alpha is 3/2. Next, we have the cosecant of alpha. Well, the cosecant of alpha is r over y. So we're going to have square root of 13 over -3. Which when we want to write it so that it doesn't have the negative in the denominator, that'll be negative the square root of 13 over 3. The secant of alpha is r over x, so square root of 13 over -2. So negative the square root of 13 over 2. And then the cotangent of alpha is x over y. So -2 over -3, or 2/3. So there you have the 6 trig ratios of alpha for that particular example. let's find the 6 trigonometric functions of points on the terminal side of an angle who have either the x or the y coordinate 0. So the first one is, my point is -3, 0. So when I think about graphing this, I have left 3, don't go up or down. So here is my trig angle and standard position, and we're calling it theta for these examples. Now when I look at that ordered pair, my x coordinate is -3, my y coordinate is 0, and if you go through and go r is equal to the square root of x squared plus y squared, we get r is equal to the square root of -3 squared plus 0 squared. Well, -3 squared is 9, 0 squared 0. So 9 plus 0 is 9, and the square root of 9 is 3. So now the sine of that theta is the y coordinate over r, and 0 divided by 3 is 0. The cosine of that angle theta is the x coordinate over r, and -3 divided by 3 is equal to -1. The tangent of that angle theta is going to be the y coordinate over the x coordinate. So 0 divided by -3, so 0 divided by -3 is 0. The cosecant of that angle theta, well, the cosecant of theta is r over y. And if I try to take 3 divided by 0, well, 3 divided by 0 is undefined. You can't divide by 0, so that's undefined. The secant of this angle theta is r over x. So 3 divided by -3 is going to give me a -1. And then the cotangent of theta is going to give me x over y, and x over y, -3 divided by 0 is undefined. Now notice this angle going from the initial side over to the terminal side, when my point on my terminal side is -3, 0, well, -3, 0 is on the negative x-axis. So if I go from the positive x-axis around to the negative x-axis, that's 180 degrees, which in radians is pi. So we really, even though technically with all of our trig functions of any angle, most generally we didn't know the angle we were working with. We just set up the ratios from our definitions and x, y, and then our r being the square root of x squared plus y squared. With these, we actually know the angles that we're talking about here because they coincide with some special angles that we are measurements that we have. So really the sine of 180 degrees, or we could say the sine of pi, is 0. And the cosine of 180 degrees, or the cosine of pi, is -1. And we can go through each of those as we make that connection between them. So for this particular one, we have that the sine of pi, or the sine of 180 degrees, is 0. The cosine of pi is -1. The tangent of pi equals 0. The cosecant of pi is undefined. The secant of pi is equal to -1, and the cotangent of pi is undefined. How about our next example? Our point being 4, 0. So go right 4 and don't go up or down. So here, our terminal side and our initial side coincide. but I have this point is 4, 0. And if I were to go through and find r, r would come out to be the square root of 4 squared plus 0 squared. So that's the square root of 16, which is 4. So then the sine of this angle, we called it theta, is y over r, so 0. The cosine of this angle theta is x over r, which is 1. The tangent of theta is y over x, which is 0. Cosecant of theta is r over y, which is undefined. And then our secant of theta is going to give me r over x, and r over x is 1. And then our cotangent of this angle theta is our x over y. So x over y would give me 4 divided by 0, which is undefined. So then with this one, I've now found the trig functions of a 0-degree angle or a 0 radian angle. So the sine of 0 is 0. The cosine of 0 is 1. The tangent of 0 is 0. The cosecant of 0 is undefined. The secant of 0 is 1. And the cotangent of 0 is undefined. So because that it actually is an angle that we can see what it would be, we could actually make that connection with those angles. How about my point being 0, -2? Don't go left or right, go down 2. So here is our angle in standard position. So there is our theta right there. And our r is the square root of 0 squared plus -2 squared. So that's the square root of 4, which is 2. So then I have the sine of theta for my point being 0, -2 is the y coordinate over r. So that's -2 divided by 2 is -1. The cosine of theta is my x over r. So that'll be 0. The tangent of theta is y over x. And so that's going to be a non-zero number divided by 0. So that's undefined. The cosecant of theta is r over y. So 2 divided by -2 is -1. The secant of theta is r over x. So this time it's undefined. And the cotangent of theta is x over y. So 0 divided by -2, which is 0. Now, do we know this angle? Well, actually we do, right? If we go from the initial side, the positive x-axis, and around to the negative y-axis, that's 90, 180, 270 degrees. So it's 270 degrees, or it is my 3 pi over 2. So these are the ratios actually if I had my 3 pi over 2 in each of these measurements for our angles, or if it's the trig functions of my 270 degrees, because they are different units but the same angle. And again, I'm only able to go to actual angle measurements from these because it coincides in the picture with something that I know the angle for. Alright, last one that we have for this type of an example is what if you have, don't go left or right, but go up 5. 1, 2, 3, 4, 5 for my point on the terminal side of the angle. My initial side is the positive x-axis vertex at the origin. That point is a point that's on the terminal side, so here is my theta. So then my sine of theta, well, we need to find our r, and r is equal to the square root of 0 squared plus 5 squared. Well, that's the square root of 0 plus 25, so it's the square root of 25, which is 5. So the sine of theta is y over r, which is 1. The cosine of theta is x over r, which is 0. The tangent of theta is y over x, which is undefined. The cosecant of theta is r over y, so 5 divided by 5 is 1. Then the secant of theta is r divided by x, which is undefined. And the cotangent of theta is my x over y, so 0 divided by 5 is 0. And because we're going from the positive x-axis to the positive y-axis, we're going 90 degrees. So that's the same as the sine of 90 degrees. And 90 degrees is halfway between 0 and 180 degrees. 180 is pi, so halfway between 0 and pi is pi over 2. So this is also the sine of pi over 2. And we could do that for all of them. I think we've done enough with the other examples that you realize that if they're asking for the sine of pi over 2, it's 1. If they're asking for the sine of 90 degrees, it's 1. If they're asking for a sine of an angle in standard position whose terminal side goes through a point on the positive y-axis, you're going to get 1. So all of these connections are starting to dovetail. So make sure that you kind of like compare and contrast and really try to hold on to what the connections are in each of these.